So if you are watching this video, hopefully you have already attempted these problems on your own. If you have not attempted these problems on your own first, please stop this video and do that first. It'll help you so much to get the practice of attempting them on your own first, and then watching the video afterwards and checking your mistakes, seeing how I did them, if I did it any differently. But you will learn and you will retain this so much better if you've tried it on your own first. So first question is showing us the graph of f, and we want to figure out which one of these could be the graph of f prime. So we want to make sure that we kind of match up that whenever f is increasing, that f prime is positive above the axis, and whenever f is decreasing, f prime is below the axis. And so what I like to do is first find my critical points, and those will be our zeros. So A does not have zeros in those points. B does have zeros at those points. C has zeros at those points, but it has an extra zero, so it can't be C. And D has 0 at those points. E doesn't have any zeros, so it can't be E. Right? And the reason those are zeros is because those are our horizontal tangent lines. Remember that basically when F has that horizontal tangent line, then f prime will be equal to 0. So next we need to just kind of match up the positives and the negatives. So this graph goes from increasing to decreasing and then back to increasing. So that means f prime needs to go from positive to negative and then back to positive. So that's B. In B, f prime was positive and then negative and then back to positive. Okay, next question we have is a tangent line question. This one's a little bit tricky, but as soon as we see that it's a tangent, we know we want to match that up with that they have the same slope. So for our first line, x plus y equals k, we can do one of two things. We can remember that m is equal to negative a over b, which would be negative 1 over 1. So just negative 1. Or you could have put this into slope-intercept form, y equals negative x plus k, and then also got in m equals negative 1. So either way you do that, you should get m equals to negative 1. Then we need to do that as well for y equals x squared plus 3x plus 1. We're going to get y prime equals to 2x plus 3, and we're going to set that equal to our slope of negative 1. So we subtract 3, we get 2x equals to negative 4, and x equals negative 2. Next, we have another tangent line question. This one's approximating f of 1.9. So we're going to do x1, y1, and m. And they told us f of 2 was equal to 1, so that gives us x as the 2 and y as the 1. They also gave us f prime of 2 was 4. Now they did tell us f double prime of 2 is 3. That's not going to help us with the tangent line. Where that would help us is that we know that it's concave up. So if it asked us, was this an under or over approximation, we would have known that this is going to be an under approximation. So now we can write our tangent line question or equation, y minus 1 equals 4 times x minus 2. And then we can replace the y with f of 1.9 is approximately 4 times 1.9 minus 2. That's going to give f of 1.9 minus 1 is approximately negative 0.1 times 4 is negative 0.4. And when we add 1, you can do backwards. 1 minus 0.4 is 0.6. All right, next, if the line tangent to the graph of the function f at the point 1 comma 7 passes through the point negative 2, negative 2, then f prime of 1 is. So we know that this is a tangent line. So what we can do is the slope of a tangent line is just back to algebra 1, y2 minus y1 over x2 minus x1. And so since we know that it has the same slope, we know that we can just use that formula. So this is negative, actually I'm going to do the 7 first, that makes more sense. So I'm going to make that my y2. So 7 minus negative 2, the y's, over 1 minus negative 2, the x's. That gives us 9 over 3, which is 3. Right, you could have also done negative 2 minus 7 over negative 2 minus 1, and then you've got negative 9 over negative 3. That works as well. All right, our next problem, which of the following is an equation of the tangent line to the graph of f at the point where x equals negative 1? So we're going to have x1, it's negative 1. For y1, we're going to plug that in. So f of negative 1 equals 4 times negative 1 cubed minus 5 times negative 1 plus 3. That's negative 4 plus 5 plus 3, which is 1 plus 3, which is 4. Then for m, we're going to take the derivative and plug in negative 1 to the derivative. So we get 12x squared minus 5 is our derivative. So m would be 12 times negative 1 squared minus 5 is 12 minus 5 is 7. So immediately I could cross out d and e because they're not 7. Then y minus 4 equals 7 times x plus 1. Now these are written in slope-intercept form, so we're going to just distribute y minus 4 equals 7x plus 7. Add the 4 over, y equals 7x plus 11. Next, we have the graph of f prime, the derivative. Make sure we always read those carefully. And it's shown between negative 2 and 5. And we want to know on what intervals is f increasing, right? So f increasing matches up with f prime positive. So from negative 2 to 0, union from 1 to 3. Now, on multiple choice, I would have written it like this, from negative 2 to 0, union from 1 to 3, and I also would have used parentheses and not brackets. Some calc textbooks are different. Some calc textbooks, negative 2 to 1. Negative 2 to 1, right? Negative 2 to 1, and then union from 1 to 3. Right, so some calc textbooks will actually combine these, and for whatever reason they don't use brackets. I feel like this is wrong, and a lot of other mathematicians feel like this is wrong. But just know on the multiple choice that this can happen. They'll never give you both of those as an answer. So it'll either be, this, or it will be this. And it really just depends on which teacher wrote the problem. So in this case, we're going to pick negative 2 to 1, and I wanted to show that just so that you're aware, if you see that on a test question, that yes, it's okay to just combine them for the purposes of multiple choice. But when you write them, I don't want you to write that. I want you to write it this way. Pretty much all of the free response answer keys will look that way. Okay, the first derivative of the function f is defined by f prime of x equals sine of x cubed minus x. On what intervals is f increasing? So this is a calculator question. First step is going to be to take f prime of x, set it equal to 0. On our calculator, we're going to do that with our solve button. So we're going to go to menu, algebra, solve, and then we had sine of x cubed minus x. Right, now we don't need to take the derivative of that because it already was the derivative. However, if this had been f of x, then first we would have taken the derivative. But since we already have f prime of x, we're just going to take that and set that equal to 0, comma x. And then outside of our parentheses, we need to do control equals. And then we want to do from 0, control equals less than x, control equals less than 2. And so that last step is important because otherwise we're going to get that weird like N1 business and it won't look right. So control enter to get a decimal. And okay, once in a while they'll throw things like this on here. And so this is good because if you get something really weird like this, it means that your calculator had a lot of trouble with the solve button. And so they want to know that you can actually do this in a different way. And so if you ever get something like this where, hey, I did put in my interval, Mr. Ewert told me to put in the interval, I still got this weird like n stuff and it just doesn't look right, do it on the graph. And on the graph, you'll get it right. So on our graph, we'll just retype that in. Menu, actions. Okay, there we go. So on our graph, we had sine. Actually, don't type it because it won't work. Sine of x cubed minus x. And then we're going to graph that. And this looks crazy, but once we fix our interval, we'll be okay. So we want to go to graph entry edit. Sorry, window. We want to go to window. We want to go to the window settings. And because this was from 0 to 2, I'm going to go from 0 to 2. I'm also going to change this from maybe like -5 to 5. Or you can leave it on the default, which is like 4 point something. Anyways, here are my zeros. So I have 2 zeros here. And so in this case, they wanted to know the when was f increasing. So it'd be in this middle section. But let's get those zeros. So we're going to go to menu, analyze graph, 0. We're going to go to the left of the 0 and to the right of the 0. That's at 1. And then we'll do it again. Menu, analyze graph, 0. The left of the 0, the right of the 0, and it's 1.69. Now, if it was on a test on free response, we would want to make sure to go to our settings and change float 3 to, like, say, float 6, somewhere around there, to make sure that we get at least 4 decimals. So anyways, this is going to be positive from 1 to 1.690. And that took care of our number line analysis too, right? Like if we did a number line on this, we would have the points 1, 1.690, 6, which is why it got rounded to 1, and then 2. And so our graph was below the axis, so it's negative, positive, and negative, and we label that as f prime. Okay, next the graph of the derivative of the function is shown above. So again, this is the graph of f prime. And they tell us that we have horizontal tangents at x equals -1, 1, and 3. And where does f of x have a minimum? Now, maximum. To get our maximum, we need to do a number line analysis for f prime, and we need to put our critical points, which are our zeros. So it's actually not those guys. Those are distractors. It's -2, 1, and 4. And so this graph is below the axis, then above the axis, and below the axis. So we're decreasing, increasing, increasing, and decreasing. So it has a maximum at 4 only. Next up, if f of x equals e to the x, which of the following is equal to f prime of e? So this is making sure that we know that definition of the derivative, right? So that's the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So that's for f prime of x, right? This is f prime of e, so we're going to plug in e. So in this case, we can either use, we have 2 formulas available. The limit as h approaches 0 of f of a plus h minus f of a over h, or we have the limit as x approaches a of f of x minus f of a over x minus a. Now none of these look like that, so it's not going to be that guy. But just so we can see what that would look like for this one, the way that one would have looked would be the limit as x approaches e, because that's the value we have, of f of x. In this case, we just replace it with e to the x, right? This is our f of x, e to the x, minus then e to the e, because we plug in, we're going to plug in e wherever we see x, over x minus e. So that's how that would have looked. But again, we don't have to worry about that for this question because none of them on the bottom have an x minus a, they all have h. So we're going with this equation here. So we have the limit as h approaches 0. Now for the a plus h, what we do is we plug in E, because E is the value we're plugging in, right? This is like the number we're plugging in, like 2 or 5 or 7, well, they're using E. So we do E. Now we plug in E plus H for X. So to the E plus H. Then minus, then we just plug in E all over H. And so the one that looks like that is choice E. All right, next up, we have another graph of the derivative. Those are very common. And which statement is true? So we know that there's our critical points are at 0, and technically 2 is an endpoint. And then f would be increasing, and now f is decreasing. And so that makes this guy a local max. So f is decreasing from -1 to 1, that's not true. F is increasing from -2 to 0, that is true. F is increasing from 1 to 2, that's not true, f prime is. F has a local min at 0, no, it has a max, and f is not differentiable at -1 and 1. This is actually not true. A lot of people will say, oh, f is not differentiable here. F is differentiable here. I know the graph makes a corner, but it's the graph of f prime. So f prime of 1 does exist. It's, whatever that y value is. Maybe this was like -3, who knows, right? So it was differentiable. But f double prime of 1 would not exist. So f is differentiable because f prime existed. But f prime, the derivative, is not differentiable. Okay, so this guy was choice B. All right, next one. I put no calculator on this. All of the ones with, that didn't say calculator were no calculator, but I just wanted to make sure that you tried this without a calculator. So we have the derivative f prime of x equals x squared minus 2 over x, and on which interval is it decreasing? So we're going to take f prime of x equal to x squared minus 2 over x, set that equal to 0. And the reason this one is a little bit tricky is that we need to get this into like a common fraction. So I'm going to do times x, and so we get x cubed minus 2 all over x equals to 0. And for critical points, we need to actually take the top equal to 0 and the bottom equal to 0. So the x cubed minus 2 case, that's going to be when we set f prime of x equal to 0. But remember, it could have also been equal to undefined. And so the denominator, x equals 0, that's going to be for our undefined case. So here we get x cubed equals 2, cube root both sides, and we get x equals the cube root of 2, and then we have x equals 0. So those are our critical points. Now we're going to make a number line, right? 0 and the cube root of 2. So I'll plug in something negative, right? Say -1 squared is 1. Minus 2 over -1, that turns positive, so this is definitely positive. Okay, next, plug in something smaller than the cube root of 2, and we could plug in 1. 1 squared minus 2 over 1 is 1 minus 2 is negative. And if we plug in something bigger than cube root of 2, like say just 2, 2 squared is 4, and 4 minus 2 over 2 is 4 minus 1 is 3, is positive. So it's increasing, decreasing, and increasing. So it says on which intervals is f decreasing? That would be from 0 to cube root of 2. All right, next up, the derivative g prime of a function is continuous and has exactly 2 zeros. Selected values of g prime are given in the table above. If the domain is the set of all real numbers, then g is decreasing on which intervals? So we know it only has 2 zeros. So g has 2 zeros. Now, g prime, the derivative of g prime has 2 zeros. So these are only 2 zeros. That's important because if they didn't tell us that, if we knew it could have a third 0, then like potentially what could have happened is even though we know that at -2 and at +2 we have zeros, technically it could have had a 0 at like -0.5, like in between here, because we just don't know what those decimal values are. But when it told us we have 2 zeros, that's important. Now we know it's there. So Here, g primes are positive. Here, g primes are negative. And here, g primes are positive. So it says, where is g decreasing? That would be in this negative section. So from -2 to 2. Next, if f is a function such that the limit as x approaches 2 of f of x minus f of 2 over x minus 2 equals 0, which of these must be true? This is that definition of the derivative, and this is at x equals 2. So this is telling us that f prime of 2 is equal to 0. Okay, that's literally what that definition tells us. So that's choice C. The derivative of f at x equals 2 is 0. We have another definition of the derivative. This is that same formula. And so what this is asking us to do is to basically just find the derivative of sine of x at x equals pi over 4. So basically step one is, okay, f of x was sine of x. On these you can always kind of just get rid of the pi over 4 or the h, and that'll be your f of x. F prime of x, then the derivative of sine of x is cosine of x. And then we want to know what is f prime of pi over 4, which is square root of 2 over 2. Now that was not an option, but remember 1 over square root of 2, that's the same thing. Right, this would give us square root of 2 over 2. Next, a polynomial has a relative max at -2, 4, a relative min at 1, 1, a relative max at 5, 7, and no other critical points. How many zeros does it have? So, right, this is pretty easy, and you can graph it if you want to. So it has a max at -2, 4, a minimum at 1, 1, and a maximum at 5, 7. So if we're going to graph that, you can see here. And so, oops, I graphed that wrong. That was a maximum. And so you can see here that we have 1, 2, 3 critical points, and those critical points are our zeros. Or you could have just kind of matched up and realized that the maximums and the minimums are the critical points, so those are the zero. Oh wait, this is my fault. It didn't ask about p prime. That would have been p prime. This says p of x, so read these carefully. So it says how many zeros does this have? So this is actually important, is this graph's going to be decreasing. Now this was a relative minimum right here. So that means that in between basically -2 and 5, it could have never gone to 0, right? This graph could have never gone down to 0. So this has 1, 2 zeros, right? P of x has 2 zeros. P prime of x, that's what I was thinking, would have had 3 zeros because those are the critical points, but P of x can only have 2 zeros because the graph, right, if it's a relative maximum at -2, 4, it would have had to be increasing before then. So somewhere it would have had to pass down to 0. And after this maximum, again, somewhere it's going to have to pass down to 0. But in between there, the minimum is at 1, 1, so it doesn't get to 0. So graphing that one actually would have really, really helped. All right, next one is the limit as h approaches 0, and this is, again, this definition of the derivative. This one is just without plugging in a number, so this is just the general one. So there's f of x. Don't include the negative. The other thing you can do is kind of just chop off the h, and then tangent of 3x is our derivative. So basically, our original f of x is tangent of 3x. And then f prime of x will be secant squared of 3x. I did jump ahead a little bit. This does have a chain rule, times 3. So we'll go over chain rule in the next one of the next videos, but there's that. Okay, next one, the derivative of f is given by f prime equals e to the x minus 3x squared. Which of these is a relative maximum? I like to actually use this on the graph. If it asks me a question like this, calculator question, I do it on the graph because it makes it so much easier. So f prime of x equals e to the x minus 3x squared. Shoot, I missed that. Let's go to actions. I should have done this in the first place. Delete all. Okay. So it was e to the x minus 3x squared. And then they don't really give us an interval, so I'm just going to start off with our standard zoom and go from there. And this looks pretty good. So there's our standard zoom. So it looks like I have 3 zeros. And we want to know which one was the relative max, right? So this is decreasing to increasing, that's a min. Increasing to decreasing, that's a max. And decreasing to increasing, that's a min. So this is the 0 I care about. So I'm going to go to Menu, Analyze Graph, 0. Go to the left of it, go to the right of it, 0.9100. So 0.91. Now, alternatively, I could have also done this with the solve button, and this is one where we could have used our solve button. So I could have gone to Menu, Algebra Solve. Oops. Menu, Algebra Solve. And then we could have done that same e to the x minus 3x squared equals 0, comma x. There's no interval, so I don't need to put one outside. And I get 3 values. I get negative 0.4589, 0.91, and 3.733. And then I could have made a number line on that. Right, but this is going to take way, way, way longer to do, is to make that number line. So negative 0.458, 0.91, and 3.73. And then I would have to plug in. So again, this is why this would take way, way longer, is we would have to come back up here, grab this guy, plug in something smaller. But I do want to show this because on, free response, if you ever have to do this, this is kind of the step that you do. So something smaller than negative 0.45 would be, say, negative 1. Control Enter to make sure we get a decimal. So I get a negative value. Then something in between negative 0.45 and 0.90. Control Enter to get a decimal. We get positive. And in between 0.91 and 3.7, you do 2. Control Enter to get a decimal. And then after 3.73, so Control Enter to get a decimal, we get positive. So we see that we have minimum, maximum, and minimum. So that's a lot longer. So on these, if you can, graphing the derivative, right? Whenever you graph the derivative, not graphing the original, but graphing the derivative, can really, really help if you're good with those patterns. Okay, the function f is given by f of x equals x cubed plus 12x minus 24. And we want to know about its increasing and decreasing habits. So again, if it were me, I would actually, if this was a graphing calculator question, I would graph that. Okay, now this is not a graphing calculator question, so we're going to have to solve for it. So equals to 0. We get 3x squared equals to negative 12. We get x squared equals to negative 4. When we square root this one's a little bit tricky, because when we square root this, we get basically no solution, right? You cannot take the derivative. So that means that there are no critical points. Okay, this is something that the AP test likes to do, is basically you have to do a number line with no critical points. That means you can plug in absolutely any value into f prime of x. So you can plug in 1, 2, 3, 4. I like to plug in 0. If I plug in 0, I get a positive. So this is always increasing. So it's increasing for all x. That kind of makes sense for a cubic function, by the way, right? Cubic functions we know kind of look like this, and so they can be always increasing. All right, next one. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t0 less than t less than 6 is given by the differentiable function c, where t is measured in minutes, and we want to use the data to approximate c prime of 3.5. So this is just the y2 minus y1, or f of b minus f of a. So 3.5 is right there. So we're going to do c of 4 minus c of 3 over 4 minus 3. That gives us 12.8 minus 11.2 over 1, which is 1.6 over 1. And so we'll say it's approximately 1.6 ounces per minute. Right? When we take the derivative, we add on a per ton. Next one's very similar. We want to approximate W prime of 12. And then using correct units, interpret the meaning. So this one was the temperature of water in a tub, where W was in Fahrenheit and T is in minutes. So in this case, we're going to say that W prime of 12 is approximately, now 12 is in between 9 and 15, so W of 15 minus W of 9 over 12 minus 9. That gives us W of 15 is 67.9 minus 61.8 over 3. And this is a calculator question, so we can do that on our calculator. So 67.9 minus 61.8 over 3, or you could even put 12 minus 9. You get 2.03 repeating. And our units will be degrees Fahrenheit per minute. So using correct units, we will say W prime of 12 represents the rate of change of the water in the tub in degrees Fahrenheit per minute at time equals 12 minutes. So derivatives are always the rate of change of, right? Integrals were the change in the amount. Next, the next one is a baby bird is gaining weight, and B of t is its weight, and dB dt then would be the rate of change of its rate. So they ask, is the bird gaining weight faster when it is 40 grams or when it weighs 70 grams? So what we need to just do is basically do B prime at 40 and do B prime at 70 and see which one is bigger. Now this was a non-calculator question, so you have to do these by hand. So this is just 1/5 times 100 minus 40, which is 60 over 5. 60 over 5 is 12. This one's going to be 1/5 times 100 minus 70. 100 minus 70 is 30. 30 divided by 5 is 6. So we can then say that the bird is gaining weight faster at time 40 because B prime of 40 was greater than B prime of 70. So this was just kind of taking the derivatives and comparing them. Another question they might ask you is like, is the bird's weight increasing or decreasing? And then you would have to figure out, is it positive? Is the derivative positive or negative? Right, next we have this waste, right? Tons of waste. And they're asking us to use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste the landfill contains at the end of the first 3 months. And they told us that's time 1/4. I'm going to do x1, y1, and m. Now, whenever we're doing times, time becomes our x1. So x1 is going to be 0. y1 is going to be basically w of 0. So let's read through this. At the beginning of 2010, a landfill contained 1,400 tons of waste. And m is our derivative. So for m, that's going to be the dw dt at time 0. So we're going to plug in. Now, normally you would plug in like time, but in this case, it's W minus 300. So W was 1400 minus 300. Right, we're plugging in the W in this case, not the time. This is 1/25. This was a little bit of a tricky question. All right, and 1100 divided by 25. So you could do this way, or you could kind of think of it in your head. 25 goes into 100 4 times. 4 times 11 is 44. But if you do it this way, you'll get the same answer. So 400 10. So then we get y minus 1400 equals 44 times x minus 0. There's our tangent line. And they say use that to approximate the value at time 1/4. And so this would be y minus 1400, approximately 44 times 1/4 minus 0. So y minus 1400 is approximately 11. So y is approximately 1411 tons of waste. Okay, that was definitely a tricky question just because we had to kind of figure out what are we, T or W, which ones are going in for X, and what do we have. Next one, we're given the rate of change of mosquitoes on an island, and we're given a rate. This is actually very similar to some of the Unit 6 stuff. And show that the number of mosquitoes is increasing at time 6. So this is a calculator question. So we just need to find R prime of 6. And so on your calculator, you just do this. Sometimes they won't say show that it's increasing. They'll just say, is it increasing or decreasing? So we have the rate already. Oh wait, this is just R of 6. This is my fault. The reason it's R of 6 and not R prime of 6 is that this is already the rate. So the rate is already R. So the number of mosquitoes increasing or decreasing is the derivative at 6, but R is already the derivative. So we want to be careful. They already gave us the derivative. So we're just going to plug it in. So 5 square root of T times cosine of T over 5. It's also good practice when you're doing these to put a multiplication sign right there. And then we want to do at times 6. And then control enter to get a decimal. We get 4.4379. If we round that, 4.4380. And so that's greater than 0, so we're increasing. So we'd say the number of mosquitoes is increasing at time 6 because R of 6 was greater than 0. And for B, at time 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? So we know it's increasing, but is that rate an increasing rate or a decreasing rate? And so the rate of the rate, that's generally f double prime of x. But remember that R was already f prime of x. So to get to f prime of x would be R prime. So when they ask this, they're just asking us to find R prime of 6. So R prime of 6, come back up here. And actually first we're going to take the derivative. So we're going to take the derivative with respect to time. And then we can come up here and hit enter. Now you want to get rid of the at times 6 inside. We need to put that outside. So the at times 6 always needs to go outside. Otherwise it'll just give you 0, and that's wrong. So at times 6 goes outside our derivative, and we get negative 1.9132. So this right here would be mosquitoes per day. This would be mosquitoes per day squared. But anyways, this is less than 0. So that means that it's increasing at the decreasing rate. So the number of mosquitoes is increasing at a decreasing rate because R prime of 6 is less than 0. On what intervals, if any, is f increasing? And so we're given a graph of f prime. So for A, when f prime is positive, then f would be increasing. So f is increasing for -3 to -2 because f prime of x is greater than 0 for that interval. And B says find an equation to the tangent line at the point 0, 3. So x1 is 0, y1 is 3. And then for M, that's our f prime. And f prime of 0 is -2. That's the value on the graph because it's the graph of f prime. So y minus 3 equals -2 times x minus 0. You can leave it like this. Don't worry about simplifying it. Just leave it like that. Okay, next we're given another graph of f prime, and we want to find our relative maximum. So when we're given a graph of f prime, we can make a number line if we want to. We don't have to. This is from -5 to 5, and so our critical points will be -3, 1, and 4. So our graph was above the axis, below the axis, above the axis, and below the axis. So the maximums are at -3 and 4. So we want to say because f prime of x changes from positive to negative at those points. Now, you didn't have to make a number line. You could have just looked at the graph and seen that at -3 and at 4, the graph changed from positive to negative as well. Okay. So I hope this helped. Email me or post on the classroom if you have any questions about any of these problems. And then my recommendation would be also to go back through the Unit 2 test as well as maybe the Unit 1 test this weekend and study those, practice them. You may even want to get a head start and try the Unit 3 or even Unit 4 tests and get a little bit ahead.